Hello everyone, this is Aditi Pal. I am a student of AIMS Nagpur. I am currently in third year. My NEET rank was 4067 and I am from Gaya, Bihar. Today we'll be continuing on the chapter solutions. In the last session we completed till multiple choice questions type 1 and today we'll be starting with multiple choice questions type 2. So in this the first question is which of the following factor and in these questions there may be two or more options correct, so we'll have to analyze all the options and mark accordingly. So the first question is which of the following factors or factor affect the solubility of a gaseous solute in a fixed volume of a liquid solvent. तो एक गैसियस सॉल्यूट है यानी कि द सॉल्यूट इज अ गैस एंड द सॉल्वेंट इज अ लिक्विड. सो ये जो फैक्टर्स हैं दैट इज द नेचर ऑफ द सॉल्यूट, टेम्परेचर एंड प्रेशर, उसमें से क्या अफेक्ट करता है द सॉल्युबिलिटी ऑफ अ गैस इन अ लिक्विड. यानी कि फॉर एग्जाम्पल इफ ऑक्सीजन इज डिजॉल्व्ड इन वाटर, ऑक्सीजन इज अ गैस. If it is dissolved in water, so what affects the solubility of oxygen in water? For example, if we take, so what affects the dissolution of gases in liquid? So first is the temperature. So जैसे जैसे temperature increase होता है, the kinetic energy of gas particles also increases, and because of the increase in kinetic energy of the gas particles, they can easily escape, which results in low concentration of gases in the liquid. So lower temperatures favor the dissolution of gases in liquid. यानी कि as the temperature increases, the molecules of gas attain kinetic energy, and because of this gain in kinetic energy they can easily escape the molecules of gas. So low, when the temperature is low, it favors the dissolution of gases in liquid. यानी कि जब वाटर फॉर एग्जांपल यहाँ पे अगर हम वाटर लेते हैं तो वाटर when it will be cold, it will favor the dissolution of oxygen or any other gas, because the molecules of oxygen will not have enough kinetic energy so that they can escape. So it will dissolve in cold water much better than that in hot water. Then what is the effect of pressure? तो जैसे जैसे प्रेशर इंक्रीज होता है the gas particles will come closer and which will increase the collision frequency. So जब collision frequency increase होगी उससे क्या होगा, the solubility of the gas in liquid will increase. So a higher pressure condition is favorable for greater concentration of gases in liquid. So likewise जब pressure increase होता है then the gases get compressed, और उसके वजह से the molecules of gas will collide more frequently with each other, and because of more collision frequently it will favor the greater concentration of gases in liquid. यानी कि जितना ज्यादा collision frequency होगा उतना molecules of gas molecules of liquid से interact करेंगे and it will favor the dissolution of the gas in the liquid. So increase in pressure will also increase the dissolution of gases in liquid. Now we come to the nature of solute. तो जो जैसा solute का nature होगा, that is the higher the solute solvent interaction, the more will be the dissolution of the solute. So अगर we know that like dissolves like, हमने ये चैप्टर में पढ़ा है कि like dissolves like, यानी जो पोलर सॉल्यूट्स होंगे they are more soluble in polar solvents while non-polar solutes are more soluble in non-polar solvent. तो नेचर ऑफ सॉल्यूट भी डिपेंड करता है. नेचर ऑफ सॉल्यूट also determines that how much will be the dissolution of the solute in the particular solvent. तो हमने देखा कि when temperature increases the kinetic energy of gas molecules increases and they have a tendency to escape rather than dissolve. Then when pressure increases, the collision frequency increases and they can interact with the liquid particles and cause dissolution. And also the nature of solute, जितना ज़्यादा interaction होगा between the solute and solvent, उतना ज़्यादा dissolution होगा. So like dissolves like, polar solutes will dissolve polar solvents and non-polar solutes will dissolve in non-polar solvents. So ये तीनों पे ही डिपेंड करता है द solubility of a gaseous solute. तो C only तो हम नहीं कह सकते, B and C only भी हम नहीं कह सकते, तीनों पे डिपेंड करता है. सो A and C यानी कि नेचर ऑफ सॉल्यूट एंड प्रेशर एट कांस्टेंट टेम्परेचर हम कह सकते हैं, एंड नेचर ऑफ सॉल्यूट एंड टेम्परेचर एट कांस्टेंट प्रेशर हम कह सकते हैं. यानी कि अगर हम टेम्परेचर को कांस्टेंट कर दें तो solubility depends on nature of solute as well as pressure both, and if we keep the pressure constant, then it depends upon the nature of solute and temperature both. So option 1 and option 2 will be the correct answer. तो अब हम आते हैं क्वेश्चन नंबर 28 पे. तो क्वेश्चन नंबर 28 says that intermolecular forces between two benzene molecules are nearly of the same strength as between two toluene molecules. For a mixture of benzene and toluene, which of the following are not true? यानी कि which of the following are false for a mixture of benzene and toluene? So first of all, we should know that a mixture of benzene and toluene, this mixture of benzene and toluene will form a ideal mixture or ideal solution, and in an ideal solution the force of interaction between A molecules and between B molecules is equal to the force of interaction between B molecules. So this इतना हमें basic पता होना चाहिए, and it is based on Raoult's law. Raoult's law के basis पे there is no positive deviation and there is no negative deviation. Ideal solution में the force of interaction between benzene molecules and the force of interaction between toluene molecules is equal to the force of interaction between benzene and toluene molecules. So इतना basic knowledge के बाद we will see that what is an ideal solution. A solution of benzene and toluene is an example of ideal solution, and an ideal solution will follow Raoult's law. So Raoult's law में Raoult's law क्या कहता है कि for a solution of volatile liquids, the partial pressure of each component of the solution is directly proportional to its mole fraction present in the solution. तो Raoult's law कहता है कि the partial pressure of each component is directly proportional to the mole fraction. So जो partial pressure है each component का, that will be directly proportional to the mole fraction. ये है Raoult's law. And ideal solution है that follows Raoult's law over entire range of concentrations. So जो ideal solutions हैं उनकी क्या properties होती है? So ideal solution में जो enthalpy of mixing the pure components to form the solution is 0, यानी कि ये ना तो endothermic है ना ही ectothermic. That means delta H of mixture is equal to 0. Then also the volume of mixing is also 0, यानी कि delta V mix is also equal to 0. So ये दोनों ऑप्शंस तो हमारे सही हो गए. डेल्टा H ऑफ मिक्सचर इज इक्वल टू 0 एंड डेल्टा V ऑफ मिक्सचर इज इक्वल टू 0. नाउ वी सी द अदर ऑप्शंस. सो दीज विल फॉर्म मिनिमम बॉइलिंग एजियोट्रोप. तो हमें पता है कि जो सॉल्यूशन फॉर्म होता है, अगर वो पॉजिटिव डेविएशन शो करता है, then it forms a minimum boiling azeotrope. तो हमने देखा these will not form, तो हमने देखा कि they are example of an ideal solution, the mixture of benzene and toluene. So they will form ideal solution, and since they are forming ideal solution, they cannot form minimum boiling azeotrope. So ये दोनों ऑप्शंस हमारे गलत हो जाते हैं. They will not form minimum boiling azeotrope and they will form ideal solution. तो ये दोनों हमारा करेक्ट आंसर होता है ऑप्शन 3 एंड ऑप्शन 4. उसके बाद हम आते हैं क्वेश्चन नंबर 29 पे. Relative lowering of vapor pressure is a colligative property because. तो इसमें हमें relative lowering of vapor pressure colligative property क्यों है वो बताना है. So we know that there are 4 colligative properties: lowering of vapor, relative lowering of vapor pressure, depression in freezing point, elevation in boiling point, and osmotic pressure. So what is a colligative property? Colligative properties are those properties that depend upon either the concentration of a non-electrolyte solute or the number of solute particles for an electrolyte solute. तो अगर non-electrolyte है solute तो उसके concentration पे depend करेगी ये colligative properties. And if it is an electrolyte, then it separates into its ions. So इसमें इसके number of solute particles पे depend करेगी. So either the solute can be an electrolyte solute, or it may be a non-electrolyte, or it may be an electrolyte. So अगर non-electrolyte है तो उसके concentration पे depend करेगी, and अगर electrolyte है तो उसके number of solute particles when it dissociates into its ions पे depend करेगी. So but it will never depend on the identity of the solute or the nature of solute particles. So इसमें जहाँ पे इसमें सारे ऑप्शंस को हमें देखना होगा. It depends on the concentration of a non-electrolyte solute in solution and does not depend on the nature of solute molecules. ये सही है. It depends on the number of particles of electrolyte. तो यहाँ पे नॉन इलेक्ट्रोलाइट था तो उसके कॉन्सेंट्रेशन पे डिपेंड कर रही थी. तो यहाँ पे जब इलेक्ट्रोलाइट होगा तो उसके नंबर ऑफ पार्टिकल्स पे डिपेंड करेगी एंड डज नॉट डिपेंड ऑन द नेचर. सिमिलरली इट डिपेंड्स ऑन द कॉन्सेंट्रेशन. तो ये भी ऑप्शन हमारा सही है. It depends on the concentration of a non-electrolyte solute as well as on the nature. No, it does not depend on the nature or identity of the solute. And उसके बाद जो ऑप्शन है, it depends on the concentration of an electrolyte or non-electrolyte solute as well as on the nature. ये भी गलत है. It never depends on the nature of the solute. It always depends on the concentration of a non-electrolyte solute. Concentration in cases of non-electrolyte and number of ions or number of solute particles in case of electrolyte, and never depends on nature. So ये इसके बेसिस पे हमारे करेक्ट ऑप्शंस होते हैं क्वेश्चन नंबर 1, ऑप्शन नंबर 1 एंड ऑप्शन नंबर 2. So ये हुआ हमारा क्वेश्चन नंबर 29. Now we come to question number 30. Question number 30 says that Van Hoff factor, that is I, is given by the expression. तो Van Hoff factor इसको हम किस एक्सप्रेशन पे दे, which of the following depicts Van Hoff factor? So Van Hoff factor का जो फॉर्मूला होता है, that is equal to, Van Hoff factor is equal to normal molar, it is the ratio of normal molar mass to abnormal molar mass. यानी कि जो हमारा नॉर्मल मोलर मास है एंड जो हम एबनॉर्मल मोलर मास, यानी कि जो एक्सपेरिमेंटली डिटरमाइंड मोलर मास है, यानी कि किसी एक्सपेरिमेंट में हमने कुछ मोलर मास ऑब्टेन किया, दैट इज एबनॉर्मल. सो नॉर्मल एंड एबनॉर्मल का जो रेशियो होता है, दैट इज Van Hoff factor. Similarly, it is also equal to observed colligative property divided by calculated colligative property. यानी कि कैलकुलेटेड कॉलिगेटिव प्रॉपर्टीज कहाँ से आती है? So they are obtained by assuming that the non-volatile solute is neither associated nor disassociated. यानी कि calculated colligative property also we are finding in any experiment, and उसके बाद हम observed and calculated का ratio निकालते हैं, then we get the want of factor. So want of factor is the ratio of normal to abnormal molar mass, and also it is the ratio of observed colligative property to calculated colligative property. So options 1 and 3 are the correct answers. तो जो want of factor होता है that is equal to the number of discrete ions in a compound, and जब इसका हम formula लिखते हैं so it is equal to normal molar mass by abnormal molar mass. Abnormal molar mass is the experimentally determined molar mass, and also it is equal to observed colligative property by calculated colligative property, which is calculated during an experiment. So these expressions are equal to the want of factor. Now we come to question number 31. So question number 31 जो है इसमें it is asking that isotonic solutions must have the same what. So what are isotonic solutions? So isotonic solutions have the same osmotic pressure. So if there are two solutions A and B, so what are isotonic solutions? So if they have the same osmotic pressure, so osmotic pressure of A is equal to osmotic pressure of B, तो इन्हें हम isotonic बोलेंगे. So they are isotonic and they also have the same concentration. तो osmotic pressure अगर same है तो we know that osmotic pressure is equal to C into R into T. तो अगर इसका osmotic pressure is equal to osmotic pressure of इसका, so at constant temperature C1 is also equal to C2, because if we take R as a variable, R is the value is constant, CRT, R is constant. If we keep temperature constant, so if osmotic pressure of A is equal to osmotic pressure of B, then concentration of A is also equal to concentration of B, and so we can say that these isotonic solutions have the same concentration. So अगर concentration same है, so the colligative properties will also be same, and because the colligative properties will also be same, so what are the colligative properties? तो मैंने बताया था कि 4 colligative properties होती है: relative lowering of vapor pressure, elevation in boiling point, depression in freezing point, and osmotic pressure. तो यानी कि इसमें से qualitative properties कौन कौन सी है? So elevation in boiling point and depression in freezing point. So ये हो जाएगा हमारा correct answers option 3 and option 4. Now we come to question number 32. Question number 32 is, which of the following binary mixtures will have the same composition in liquid and vapor phase? तो इसमें से कौन से binary mixtures यानी mixture of two components will have the same composition in liquid and vapor phase? So benzene, toluene, water nitric acid, water ethanol, and N-hexane and N-heptane. For having the same composition in liquid and vapor phase, the mixture should be azeotropic mixture, यानी it should either show positive deviation from Raoult's law or it should show negative deviation from Raoult's law. तभी ये azeotropic mixture होगा, and then only it can have the same composition in liquid and vapor phase. So liquid and vapor phase में same composition होने के लिए they should not be an ideal solution, and इसमें से हमें पता है कि benzene and toluene will form an ideal solution, and also N-hexane and N-heptane will also form an ideal solution. तो ये दोनों तो हमारे ideal हो गए. Water and nitric acid जो solution बनाता है, it is an example of showing large negative deviation from Raoult's law, and if it is showing negative deviation from Raoult's law, then it will form maximum boiling azeotrope. and अगर maximum boiling azeotrope बनेगा, so they will have the same composition in liquid and vapor phase. So same composition at liquid and vapor phase होगा with a boiling point of 393.5 Kelvin. And also जो water and ethanol mixture होगा, it will show large positive deviation from Raoult's law, and positive deviation show करने के वजह से it will form minimum boiling azeotrope. And अब जब minimum boiling azeotrope बनेगा, so at a particular temperature जो उसका boiling temperature होगा, उसमें it will have the liquid phase and vapor phase will have the same composition. And once this composition is known as azeotropic composition has been achieved, the liquid and vapor phase will have the same composition. So जब हम इथेनॉल एंड वाटर के मिक्सचर को हम फ्रैक्शनल डिस्टिलेशन करते हैं, तो उससे हमें एक सॉल्यूशन मिलता है कंटेनिंग 95% बाय वॉल्यूम ऑफ इथेनॉल. एंड उसके बाद जो है लिक्विड एंड वेपर फेज का सेम कॉम्पोजिशन होता है एंड नो फर्दर सेपरेशन अकर्स, यानी कि वो फर्दर सेपरेट नहीं होता. दैट इज द मैक्सिमम पॉइंट टिल विच इट कैन बी सेपरेटेड. सो they show a positive deviation from Raoult's law, and they also form minimum boiling azeotrope. And इसके वजह से the correct options will be water and nitric acid and also water and ethanol. तो ये हो गया हमारा क्वेश्चन नंबर 32 भी. Now we come to question number 33, that is in isotonic solutions what are the correct options. तो isotonic solutions में क्या क्या होता है? Solute and solvent both are same. Osmotic pressure is same. Solute and solvent may or may not be same. Solute is always same. Solvent may be different. तो इसमें से क्या क्या सही है for an isotonic solution? So we already saw that an isotonic solution is the solution. आइसोटोनिक सॉल्यूशंस वो होते हैं जिनका ऑस्मोटिक प्रेशर सेम होता है. सो आइसोटोनिक सॉल्यूशन में ऑस्मोटिक प्रेशर सेम होगा. सो ऑप्शन 2 तो हमारा करेक्ट है. एंड ऑल्सो जरूरी नहीं है कि फॉर ऑस्मोटिक प्रेशर टू द सेम द सॉल्यूट एंड सॉल्वेंट पार्टिकल्स मे नॉट बी सेम, क्योंकि इसका सिर्फ एक क्राइटेरिया है, दैट इज ऑस्मोटिक प्रेशर शुड बी सेम. सॉल्यूट एंड सॉल्वेंट का सेम होना इज नॉट अ क्राइटेरिया फॉर कॉलिंग इट एन आइसोटोनिक सॉल्यूशन. सो सॉल्यूट एंड सॉल्वेंट बोथ आर सेम, नॉट नेसेसरी. सॉल्यूट एंड सॉल्वेंट मे और मे नॉट बी सेम. इट इज अ करेक्ट ऑप्शन बिकॉज हो सकता है सॉल्यूट एंड सॉल्वेंट सेम हो, पर हो सकता है दे आर नॉट द सेम, बट इफ दे हैव द सेम ऑस्मोटिक प्रेशर then they will be called isotonic solutions. So osmotic pressure is the same and solute and solvent may not be same are the correct answers. So ये हो गया हमारा question number 33. Now we come to question number 34. For a binary ideal liquid solution, the variation in total vapor pressure versus composition of solution is given by which of the following curves? So एक बाइनरी आइडियल लिक्विड सॉल्यूशन है, तो उसमें जो टोटल यानी कि इसके 2 कंपोनेंट्स हैं A and B. If we consider the 2 components of this binary ideal liquid solution, so total vapor pressure versus composition of solution is given by which curves? So अगर हम total vapor pressure को देखें, so it will total vapor pressure is तो हमें पता है कि partial pressure is directly proportional to the mole fraction. तो अगर हम partial pressure को एक constant से हटाएं तो P is equal to KH into mole fraction. तो ये हो गया partial pressure of A and ये हो जाएगा हमारा partial pressure of B, KH into X3, X1 and X2 हम ले लेते हैं according to the question. तो total pressure हो जाएगा PA plus PB. हम किसी भी टाइम पे निकाले तो ये टोटल प्रेशर इतना ही रहेगा. सो P is equal to KH X1 plus KH X2. तो अगर हम एक टाइम पे फॉर एग्जांपल फॉर हेयर x1 x1 is if we take x1 is equal to 0 at where it is starting, so p is equal to kh into x2, that is y is equal to mx के फॉर्म में आ रहा है. So the graph will be a straight line. So graph कभी भी ऐसा नहीं होगा. And अगर हम x1 को 0 ले लें, तो x1 को नहीं x2 को 0 ले लें, तो p is again equal to kh into x1, that is again it is equal to y is equal to mx. So kabhi bhi graph will always be in straight line, it will not be in a curve line, because y is equal to mx का graph हमें पता है that it is always a straight line. तो इसमें जो करेक्ट आंसर होगा वो हो जाएगा हमारा ऑप्शन नंबर 1 एंड ऑप्शन नंबर 4, because it will always be a straight line and not curved line. So with the equation we find out that जो equation आएगी हमारा that will equal to be y is equal to mx के फॉर्म में, whose graph is a straight line. Now we come to question number 35, that is colligative properties are observed when. तो हम colligative properties को कब observe करते हैं? तो कभी भी जो एक सॉल्यूशन होता है उसमें अगर एक कंपोनेंट जो है अगर वॉलेटाइल है, so it will cause deviation from ideal behavior and vapor pressure of solution which causes change in colligative property. तो जब भी एक वॉलेटाइल कंपोनेंट होता है, फॉर एग्जाम्पल हम ऑप्शंस में देखें तो एक गैस विच इज वॉलेटाइल इट डिजॉल्व्ड इन अ नॉन वॉलेटाइल लिक्विड, एंड ऑल्सो वॉलेटाइल लिक्विड इज डिजॉल्व्ड इन अनदर वॉलेटाइल लिक्विड. सो कोई भी कंपोनेंट अगर वॉलेटाइल होगा या तो दोनों कंपोनेंट्स वॉलेटाइल होंगे, so they will cause deviation from ideal behavior, and if there is deviation from ideal behavior and also deviation of the vapor pressure, and they'll cause a change in colligative property. So हमेशा non volatile solids पे depend जो colligative properties होता है that is applied on non volatile compounds. अगर एक भी component और या तो दोनों component अगर volatile हैं तो colligative properties won't apply. So the correct options are option 1 and option 2. Non-volatile solid is dissolved in a non-volatile liquid, and also non-volatile liquid is dissolved in another non-volatile liquid. So we can observe colligative properties easily. तो ये हो गए हमारे MCQs type 2 खत्म. Now we come to short answer type questions. Short answer type questions में the first question is, components of a binary mixture of two liquids A and B were being separated by distillation. After some time, separation of components stopped and composition of vapor phase became same as that of liquid phase. Both the components started coming in the distillate. Explain why this happened. तो हमने एक क्वेश्चन में देखा था कि जो azeotropic solutions होते हैं, when the azeotropic composition is attained, then the composition in vapor phase is equal to the composition in the liquid phase, and इसके बाद जो होता है हमारा fractional distillation stop हो जाता है because the compositions are equal, stop हो जाता है. So azeotropic solutions are binary solutions that have the same composition in the liquid and vapor phase and boil at a constant temperature. The components of an azeotropic solution cannot be separated by fractional distillation. An example of azeotropes is the ethanol water mixture formed after fermentation of sugars. तो उसमें भी हमने ethanol and water का example देखा था. So both the components are appearing in the distillate and the composition of the liquid and vapor is the same. This shows that the liquids have formed an azeotropic mixture and hence cannot be separated at this stage by fractional distillation. यानी कि जब ये एक ऐसे पॉइंट पे पहुंच जाते हैं when the composition in the solid phase in the liquid phase and vapor phase is same, तो इन्हें हम azeotropic solution बोलते हैं. And azeotropic solutions cannot be separated further by fractional distillation. ये वहीं पे रुक जाता है. So fractional distillation of the water ethanol mixture gives a solution of 95% ethanol. यानी कि 95% ethanol तक तो separate हो गया, पर यहाँ इस लिमिट के बाद the solution of ethanol and water, it formed an azeotropic solution, and because it formed an azeotropic solution, further fractional distillation cannot take place. 95% से हम 100% इथानॉल को सेपरेट नहीं कर पाएंगे by fractional distillation. तो ये जो क्वेश्चन में जो हमें पूछ रहा है, that is similar to this example. So in this composition, the liquid and vapor will have the same constant composition and no further separation occurs. That means it was the limit of separation. Now इसके बाद कोई separation नहीं होगा by fractional distillation. So at this point, the mixture of ethanol and water has reached the azeotropic solution. तो इस क्वेश्चन में भी जो two liquids हैं, they have reached the azeotropic. They have formed an azeotropic solution at this point, in which the composition of both liquid and vapor phase is the same, and no further separation of components will occur. Now, question number 37. Explain why on adding 1 mole of NaCl to 1 liter of water, the boiling point of water increases, while addition of 1 mole of methyl alcohol to 1 liter of water decreases its boiling point. तो जब हम 1 liter of water में 1 mole of NaCl add करते हैं, तो boiling point increase हो जाता है, पर similar क्वांटिटी ऑफ वाटर में अगर हम 1 मोल ऑफ मिथाइल अल्कोहल ऐड करते हैं तो उसका बॉइलिंग पॉइंट डिक्रीज हो जाता है. सो व्हाई डज दैट हैपन? सो वी नो दैट जो हमारा NaCl है, दैट इज अ नॉन वोलेटाइल सॉल्यूट. तो जब हम इसको पानी में के अंदर डालेंगे, इफ वी ऐड NaCl टू वाटर, देन द वेपर प्रेशर ऑफ वाटर विल डिक्रीज. यानी कि NaCl के एडिशन से जो वाटर का वेपर प्रेशर है वो कम हो जाएगा. तो जो वाटर मॉलिक्यूल्स है, वाटर जो बॉइलिंग पॉइंट ऑफ वाटर है वो इंक्रीज हो जाएगा, बिकॉज जो वाटर मॉलिक्यूल्स है उनका इफेक्टिव सरफेस एरिया जो है, वाटर मॉलिक्यूल्स का इफेक्टिव सरफेस एरिया वो डिक्रीज हो जाएगा. एंड बिकॉज द इफेक्टिव सरफेस एरिया डिक्रीजेस, दे कैन नॉट एस्केप like they were escaping before. So vapor pressure also decreases, and vapor pressure, since it decreases, the boiling point of water will increase. So जो solution होगा उसका boiling point increase हो जाएगा. तो that is why the addition of NaCl की वजह से जो boiling point है वो increase हो रहा है, because the vapor pressure is decreasing. Whereas जब हम मिथाइल अल्कोहल डालते हैं, तो जो मिथाइल अल्कोहल होता है, दैट इज मोर वॉलेटाइल देन वाटर, यानी कि वो वाटर से भी ज्यादा वॉलेटाइल है. सो इसके एडिशन की वजह से जो टोटल वेपर प्रेशर है, जो वेपर प्रेशर इस मिथाइल अल्कोहल के एडिशन की वजह से इंक्रीज हो जाएगा. एंड इफ वेपर प्रेशर इंक्रीजेस, देन बॉइलिंग पॉइंट डिक्रीजेस. सो जब हम मिथाइल अल्कोहल को वाटर में डालेंगे तो टोटल वेपर प्रेशर इंक्रीज हो जाएगा, एंड बिकॉज ऑफ द टोटल increase in vapor pressure, there will be a decrease of boiling point. So if there is 1 liter of water and we add 1 mole of NaCl, then its boiling point increases, but when we add 1 mole of methyl alcohol, its boiling point decreases. Now we come to question number 38. Explain the solubility rule, like dissolves like, in terms of intermolecular forces that exist in solutions. तो जो intermolecular interactions होते हैं in solutions, तो they are similar in both constituents, that is in solute and solvent. Then solute dissolves in the solvent. तो जो अगर solute and solvent के बीच अगर intermolecular attractions, if they are same, then only the solute will dissolve in the solvent. Like for example, the polar solutes dissolve in polar solvents and non-polar solutes dissolve in non-polar solvent. यानी कि अगर हम एक polar solute ले लें, that is for example NaCl, तो NaCl हमारा water में dissolve करता है, salt हमारा NaCl हमारा water में dissolve करता है, so NaCl will dissociate into Na plus and Cl minus, and water dissociates into H plus and OH minus. So they are similar. They have the similar intermolecular forces. They separate into ions. So like will dissolve like, यानी कि एक आयन हमारा एक ऑर्गेनिक सॉल्वेंट में डिसॉल्व नहीं करेगा, बट एक ऑर्गेनिक सॉल्यूट हमारा ऑर्गेनिक सॉल्वेंट में डिसॉल्व कर जाएगा, बिकॉज द intermolecular forces in between the solute and solvent are similar. So due to similar intermolecular interactions, the solute will attract the solvent, and thus the solute and solvent will dissolve in each other. So इससे हम explain कर सकते हैं the rule like dissolves like. Polar will favor a polar solvent, polar solute, polar solvent, and non-polar solute, non-polar solvent. Now we come to question number 39. Concentration terms such as mass percentage, ppm, parts per million, mole fraction, and molality are independent of temperature. However, molarity is a function of temperature. Explain. So जो ये सारे terms हैं, they are independent of temperature, but molarity is not independent of temperature. So why is it like that? So what is molarity? Molarity is equal to the number of moles of solute. It is equal to the number of moles of solute divided by volume of solution. और बाकी सब में कहीं पे भी volume का term नहीं आएगा in these in the other expressions. There is no relation of volume, since इस molarity के equation में volume है, and volume depends upon the temperature and changes with temperature. So जो volume है वो change होता है with temperature. So अगर volume change होगा temperature के साथ, so molarity भी change होगी, and that is why because of the existence of volume in the equation of molarity, it changes with temperature, while on the other hand mass has no effect with temperature. Mass हमेशा same रहता है, and other concentration terms जो है mass percentage, ppm, mole fraction, molality, they are all functions of mass, यानी कि इनके equation, इनके formula में mass आता है, and mass does not change with temperature. So other concentration terms given in the question also do not do so. The temperature has no effect on the mass, but it has significant effect on volume. So since temperature has an effect on volume, so it will have an effect on molarity, and that is why molarity is a function of temperature, because volume is dependent upon temperature. Now we come to question number 40. What is the significance of Henry's law constant kh? तो Henry's law constant kh का क्या significance है? So the Henry's law states that at a constant temperature, the solubility of a gas in a liquid is directly proportional to the partial pressure of the gas present above the surface of the liquid or solution. यानी कि we know that partial pressure is equal to kh into x, where x is the solubility of gas in the liquid. So जो solubility of gas होती है in liquid, that is directly proportional to the partial pressure of the gas present over the surface of liquid. तो अगर ये partial pressure of x है, so partial pressure is equal to kh into x, where x is the solubility of the gas in the liquid. तो ये होता है हमारा Henry's law, and Henry's law constant होता है kh. kh is the Henry's law constant. तो इसका significance क्या है? Henry's law states that the partial pressure of gas in the vapor phase is proportional to the mole fraction of the gas in the solution. यानी कि the partial pressure of gas in the vapor phase is proportional to the mole fraction. तो अगर एक गैस लिक्विड में डिसॉल्व है तो उसका जो पार्शियल प्रेशर होगा दैट विल बी डायरेक्टली प्रोपोर्शनल टू इट्स सॉल्युबिलिटी, एंड अगर एक वेपर फेज में है देन द partial pressure of the gas is directly proportional to the mole fraction of the gas. तो मोल फ्रैक्शन पे डिपेंडेंट होगा इन वेपर फेज. तो हेनरीज लॉ कांस्टेंट होता है हमारा KH. एंड व्हाट इज द सिग्निफिकेंस ऑफ KH? तो यहाँ से हम देखें अगर तो KH इज इक्वल टू PX डिवाइडेड बाय सॉल्युबिलिटी. तो KH इज इनवर्सली प्रोपोर्शनल टू सॉल्युबिलिटी. तो KH सिंस इट इज अ कांस्टेंट इट विल बी फिक्स्ड फॉर डिफरेंट गैसेस. तो यानी कि अगर KH की वैल्यू ज्यादा होगी तो सॉल्युबिलिटी ऑफ गैस लो होगा, और KH की वैल्यू कम होगी तो सॉल्युबिलिटी ऑफ गैस विल बी हाई. So on the basis of this we can say that KH is dependent upon the solubility. So KH determines that the solubility of the gas in the liquid. So higher the value of Henry's constant, the lower is the solubility, and Henry's law plays an important role in atmospheric and environmental chemistry as well as wastewater treatment plants. Because of Henry's law we can determine the solubility of a gas in a liquid, and solubility को हम determine करके use कर सकते हैं in atmospheric and environmental chemistry as well as also in wastewater treatment plants. अब हम आते हैं क्वेश्चन नंबर 41 पे. Why are aquatic species more comfortable in cold water in comparison to warm water? तो aquatic species why are they comfortable in cold water? तो ये हमारे 2 क्वेश्चंस का मिला हुआ एक क्वेश्चन है. तो सबसे पहले हमने पढ़ा था कि जब वाटर हमारा कोल्ड होता है, so when water is cold then the solubility of gas in water will be more, because the gas molecules will not have enough kinetic energy to escape. तो cold water में जो gases की solubility है वो ज्यादा होगी. So and also according to Henry's law P is equal to KH into solubility, and KH Henry's law's constant is a function of temperature. So जैसे जैसे temperature increase होता है KH also increases, and if KH increases, KH is inversely proportional to solubility, and if KH increases यानी कि solubility is decreasing. So जैसे जैसे temperature बढ़ता है KH also increases, and because of the increase in KH the solubility decreases. So at higher temperature the value of KH is high and the solubility is low, and because the solubility is low, अगर solubility low होगी तो amount of dissolved oxygen in the liquid is also low. यानी कि जो cold water है उसमें यानी कि जो hot water है उसमें ऑक्सीजन की क्वांटिटी लो है, लो ऑक्सीजन, एंड द कोल्ड वाटर उसमें ऑक्सीजन की क्वांटिटी ज्यादा है. बिकॉज ऑफ हेनरीज लॉस कांस्टेंट इंक्रीजिंग द सॉल्युबिलिटी ऑफ गैस डिक्रीजेस, एंड आल्सो वी नो दैट अगर वाटर वार्म होता है then the molecules of gas have a higher kinetic energy and they can escape, so the solubility decreases if temperature is more. So amount of dissolved oxygen in water decreases with the rise in water's temperature. Cold water has more dissolved oxygen per unit area than warm water, and because it has more dissolved oxygen, so the aquatic species are more comfortable in cold water. So ये हो गया हमारा reason why aquatic species are more comfortable in cold water. Now we come to question number 42. Explain the following phenomena with the help of Henry's law. Painful condition known as bends, feeling of weakness and discomfort in breathing at high altitude. So painful condition known as bends पे हम आते हैं पहले. So Henry's law is equal to P is equal to KH into X. It represents a relation between solubility of gases in liquid solubility of gases in liquid and pressure. Scuba divers, when come towards the surface, the pressure gradually decreases. तो जो हेनरीज लॉ है दैट इज अ रिलेशन बिटवीन प्रेशर एंड सॉलिबिलिटी ऑफ गैसेस. तो जैसे जैसे स्कूबा डाइवर्स सरफेस पे आते हैं तो प्रेशर ग्रेजुअली डिक्रीजेस. एंड अगर प्रेशर डिक्रीज होता है, हमें पता है कि स्कूबा डाइवर्स दे गो टू ग्रेट डेप्थ्स इन द वाटर एंड यहाँ पे प्रेशर बहुत ज्यादा है. प्रेशर बहुत ज्यादा है तो सॉलिबिलिटी ऑफ गैसेस इंक्रीज हो गई. एंड जैसे जैसे वो ऊपर आए प्रेशर अचानक से बहुत कम होने लगा. बिकॉज ऑफ दैट सॉलिबिलिटी डिक्रीजेस. तो यहाँ पे गैसेस लाइक नाइट्रोजन गॉट डिसॉल्व्ड इन द, वो हमारे ब्लड को एंटर करके दे एंटर्ड इनटू द टिश्यूज. बट जैसे जैसे हम ऊपर गए ये बाहर निकलने की कोशिश करेंगे बिकॉज ऑफ डिक्रीज इन सॉल्युबिलिटी, बट दे विल नॉट बी एबल टू एस्केप. एंड व्हेन दे आर एस्केपिंग दे विल रिजल्ट इन फॉर्मेशन ऑफ बबल्स ऑफ नाइट्रोजन इन द ब्लड. एंड बबल्स ऑफ नाइट्रोजन जो है वो निकल भी नहीं पाएंगे जल्दी जल्दी. एंड दैट क्रिएट्स अ पेनफुल कंडीशन बाय ब्लॉकिंग कैपिलरीज व्हिच इज नोन एज बेंड्स. यानी कि because of going to greater depths and increase in pressure, nitrogen entered in the blood and it got dissolved. But when we come on the surface, then pressure drops all of a sudden, and this drop in pressure causes the decrease in solubility of nitrogen, and nitrogen tries to escape as bubbles and blocks capillaries. And because of this blocking of capillaries, it results in a painful condition which is known as bends. तो ये रीजन होता है हमारा bends का. Then feeling of weakness and discomfort in breathing at high altitude. तो जब हम high altitude पे जाते हैं, so atmospheric pressure is low. Atmospheric pressure low होगा तो solubility of oxygen in the blood will also be low. And अगर oxygen ही नहीं है blood में, तो it will cause difficulty in breathing at high altitude. So इसके वजह से हमें anoxic feel होता है, we feel discomfort, we feel confused. So when we go at a high altitude, atmospheric pressure decreases, because of which solubility also decreases, and solubility of oxygen decreases. Oxygen decreases in our tissues and blood, which results in anoxia and causes discomfort to us. Now we come to question number B. Why soda water bottle is kept at room temperature, fizzes on opening? तो जो सोडा वाटर बॉटल होती है वो क्यों फिज करती है on opening? Because of different pressure inside and outside the bottle. So when the bottle is open to air, the partial pressure of CO2 above the solution decreases. As a result, solubility decreases and hence CO2 bubbles out. So अगर हम सोडा वाटर बॉटल को रूम टेम्परेचर पे ओपन करेंगे तो जो पार्शियल प्रेशर ऑफ CO2 अबव द सॉल्यूशन है, CO2 का जो पार्शियल प्रेशर अबव द सॉल्यूशन है, that will decrease because CO2 is escaping out. So CO2 का पार्शियल प्रेशर डिक्रीज होगा अबव द सॉल्यूशन एंड उसके वजह से CO2 की सॉल्युबिलिटी भी डिक्रीज होगी. एंड बिकॉज द सॉल्युबिलिटी इज डिक्रीजिंग, CO2 जो सॉल्यूशन में है वो भी बाहर आएगा. सो इट विल क्रिएट अ फिज. बिकॉज CO2 का पार्शियल प्रेशर कम हो रहा है तो सॉल्युबिलिटी विल आल्सो डिक्रीज एंड CO2 विल स्टार्ट कमिंग आउट एज फिज. इसलिए हमारा सोडा वाटर बॉटल फिजेस एट रूम टेम्परेचर ऑन ओपनिंग. Now we come to question number 43. Why is the vapor pressure of an aqueous solution of glucose lower than that of water? तो एक aqueous solution of glucose है. Why is it lower than that of the उसका vapor pressure is lower than that of water? Because glucose एक solute है and solute को जब हम water में add करते हैं, so जो liquid का surface area है that decreases. Now the surface of liquid consists of both solute and solvent molecules. यानी कि पहले सिर्फ water था, ग्लूकोज भी है and water भी है, यानी the effective surface area for water is decreasing. तो vapor pressure is also decreasing. इसलिए जो vapor pressure है वो डिक्रीज होगा एंड escaping tendency of solvent molecules will also reduce. तो जो वाटर पहले जितना फ्रीली एस्केप कर रहा था, अब वो ग्लूकोज मॉलिक्यूल्स के वजह से उतना फ्रीली एस्केप नहीं कर पाएगा, एंड सिंस इट इज नॉट एबल टू एस्केप फ्रीली, then it will not be able to create a vapor pressure on the surface of water molecules, because the water molecules के बीच में कहीं कहीं ग्लूकोज मॉलिक्यूल्स होंगे. So effective surface area decreases and thus the vapor pressure also decreases, and vapor pressure decrease हो जाता है if we add glucose to a solution of water. ग्लूकोज को हम अगर वाटर में डालते हैं तो जो सॉल्यूशन होता है उसका वेपर प्रेशर इज लेस देन दैट ऑफ वाटर. नाउ क्वेश्चन नंबर 44. हाउ डज स्प्रिंकलिंग ऑफ सॉल्ट help in clearing the snow covered on roads and hilly areas? Explain the phenomenon involved in the process. तो जब हम सॉल्ट को स्नो पे स्प्रे करते हैं तो स्नो स्टार्ट्स मेल्टिंग. सो व्हाई डज इट हैपन? सो जो राउल्स लॉ है वो कहता है कि when a non-volatile solute is added to a solvent, the vapor pressure of the solvent decreases, and now this pressure would be equal to the vapor pressure of the solid solvent at a lower temperature. Thus, the freezing point of the solvent decreases with the addition of a non-volatile solute. यानी कि according to Raoult's law, अगर हम एक non-volatile solute को एक सॉल्वेंट में ऐड करते हैं तो उस सॉल्वेंट का जो फ्रीजिंग पॉइंट है वो डिक्रीज हो जाता है बिकॉज ऑफ द एडिशन ऑफ नॉन वॉलेटाइल सॉल्यूट. सो जब हम सॉल्ट को स्प्रेड करते हैं ओवर स्नो कवर्ड रोड्स तो जो वाटर पॉइंट है वो फ्रीजिंग पॉइंट है वाटर का वो डिक्रीज हो जाता है, ड्यू टू विच द स्नो ऑन द रोड स्टार्ट्स टू मेल्ट. तो जब हम सॉल्ट को स्प्रेड कर रहे हैं वो स्नो कवर्ड रोड, स्नो स्टार्ट्स मेल्टिंग फ्रॉम द सरफेस बिकॉज ऑफ द डिप्रेशन ऑफ फ्रीजिंग पॉइंट ऑफ वाटर takes place due to the addition of salts, and it helps in cleaning of roads. So जो phenomenon of depression and freezing point है, जब हम एक non volatile solute को एक solvent में add करते हैं तो according to Raoult's law जो freezing point है solvent का वो decrease हो जाता है, and because of the decrease in freezing point the solvent starts to melt. यानी कि जो स्नो में जो वाटर से स्नो बना है उसका फ्रीजिंग पॉइंट डिक्रीज होगा एंड द स्नो विल स्टार्ट मेल्टिंग. सो दिस इज द रीजन कि जब हम सॉल्ट को स्प्रे करते हैं ऑन स्नो कवर्ड रोड्स देन द स्नो स्टार्ट्स मेल्टिंग. Now we come to question number 45. What is a semi-permeable membrane? So a semi-permeable membrane is a membrane through which only smaller molecules like water can pass, but bigger molecules like solutes cannot pass, and it is known as semi-permeable membrane or SPM. So semi-permeable membrane एक ऐसी membrane है through which only small molecules like water can pass, but big solute molecules cannot pass, and these semi-permeable membranes can be of animal or vegetable origin, and these can occur naturally such as pig's bladder or parchment, or it can be synthetic such as cellophane. So ये membranes जो है they appear to be continuous sheets or films, yet they contain a network of sub-microscopic holes or pores through which smaller solvent molecules can pass. Cellulose, acetate, potassium, ferrocyanide ये examples हैं of semi-permeable membrane. So semi-permeable membrane क्या होती है? Semi-permeable membrane or SPM is a type of membrane. इसमें बहुत माइक्रोस्कोपिक होल्स होते हैं, एंड बिकॉज ऑफ दीज माइक्रोस्कोपिक होल्स सॉल्वेंट्स पास कर सकते हैं एंड सिलेक्टेड सॉल्यूट्स भी पास कर सकते हैं विच आर वेरी स्मॉल, एंड इट डज नॉट अलाउ द मूवमेंट ऑफ बिग सॉल्यूट्स. तो बिग सॉल्यूट्स का मूवमेंट इज नॉट possible through semi-permeable membrane. It allows the movement of only small solutes and that also selected solutes. तो हम पढ़ते हैं अपने animal cells की cell membrane is a semi-permeable membrane and it allows the movement of solvent molecules and also selected solutes through it. So it is not fully permeable, it is semi permeable. तो हम semi permeable इसीलिए बोलते हैं. So semi permeable membrane is a membrane that allows the movement, allows smaller molecules like water to pass, but not the bigger molecules like solutes, is known as semi permeable membrane. Examples हमने देखे, cellulose acetate and potassium ferrocyanide, they are examples of a semi permeable membrane. Now we come to question number 46. Give an example of a material which are used for making semi permeable membranes for carrying out reverse osmosis. So semi permeable membranes का हमें example देना है, example of a material. So continuous sheets of or films that contain a network of sub-microscopic holes or pores through which small solvent molecules like water can pass, but not the bigger molecules of solute, is known as a semi-permeable membrane. ये तो हमने पिछले ही क्वेश्चन में देखा था कि there are continuous sheets or films that contain network of sub-microscopic holes through which small solvent molecules like water can pass, पर बिग सॉल्यूट मॉलिक्यूल्स नहीं पास कर सकते, उसे हम सेमी परमेबल मेम्ब्रेन बोलते हैं. एंड वी आल्सो सॉ दैट वी कैन यूज सेल्यूलोज एसीटेट फॉर मेकिंग सेमी परमेबल मेम्ब्रेन, एंड आल्सो वी कैन यूज पोटेशियम फेरोसाइनाइड. तो ये होते हैं हमारे टू एग्जांपल्स ऑफ अ मटेरियल व्हिच कैन बी यूज्ड टू मेक सेमी परमेबल मेम्ब्रेन. ये हो गया हमारा क्वेश्चन नंबर 46. अब हम आते हैं मैचिंग टाइप ऑफ क्वेश्चंस पे. उसमें क्वेश्चन नंबर 47 है, तो हमें इन्हें अपने डेफिनेशंस के साथ मैच करना है. सो व्हाट इज अ सैचुरेटेड सॉल्यूशन? अ सॉल्यूशन व्हिच कंटेन्स maximum amount of solute that can be dissolved in a given amount of solvent is at a given temperature. So when temperature is constant, the maximum amount of solute that can be dissolved in a given amount of solvent, तो हम ऐसे solution को saturated solution बोलते हैं. Now we come to option number 2, binary solution. Binary नाम से ही हमें पता चल रहा है binary is equal to 2. So a solution with two components will be a binary solution. Then isotonic solution, हमने 3 बार पढ़ा आज कि the solutions with same osmotic pressure at a given temperature are known as isotonic solution. So isotonic के लिए same osmotic pressure होना चाहिए. Solution having the same atmospheric pressure, osmotic pressure at a given temperature as that of a given solution. तो हम उन दोनों solutions को isotonic बोलते हैं. Hypotonic solution, isotonic, hypotonic and hypertonic. So hypo आता है पहले, then iso, then hyper. तो hypo में जो osmotic pressure होगा, a solution of whose osmotic pressure is less than that of another. Hypertonic में जो osmotic pressure होगा, that will be more than that of another. And solid solution will be a solution in solid phase. ठीक है, तो इससे हम आंसर्स ए का होता है हमारा डी, 1 का होता है हमारा डी, 2 का होता है सी, 3 का ए, 4 का बी, 5 का एफ एंड 6 का ई. तो ये हुआ हमारा क्वेश्चन नंबर 47 ऑफ मैचिंग टाइप. एंड आज के लिए इतना ही. बाकी सारे क्वेश्चंस हम नेक्स्ट सेशंस में खत्म करेंगे. तब तक के लिए थैंक यू एवरीवन एंड कीप स्टडीइंग.